All right. So one of my all-time favorite things in the entire seventh grade curriculum to teach is solving equations. And today is really the foundation for solving one-step equations. And you'll notice that we are now at the start of November. We are well into trimester one, past the halfway point. And in order to get here to the real meat of the algebra, we had to do all of the how do you add, how do you subtract, how do you multiply, and how do you divide in order to be able to do the first layer of solving these one-step equations. And in order to solve a one-step equation, we have to first know that an equation has to have an equal sign. If it doesn't have an equal sign, then it's an expression, and we cannot solve those. We simplify those, which is what we've been doing. So solving an equation first relies on the fact that there is an equal sign, and we're going to use something called inverse operations. They're the operations that undo each other. So adding and subtracting will undo each other because if you add 6 and then subtract 6, you get back to where you started. So in the first equation here, we've got y minus 5 equals 10, and our goal is to solve for y. So the inverse, or the opposite of subtracting 5 from the variable we're trying to find, would be to add 5. And in order to have things stay equal or balanced, we have to do things to both sides of the equation. So what we're going to do in order to get rid of this minus 5, our goal being to get the y by itself, we're going to add 5 on the left side of the equation and add 5 on the right side of the equation. Now, please understand that the first thing I said about this was we are trying to get y by itself. So we're always going to look at the side of the equation that has the variable and say, how can we get rid of whatever else is bothering the variable? So right now, y minus 5, I want to get rid of the subtract 5. So the inverse of that is to add 5. But in order to keep this balanced, or equal on the left and equal on the right, I have to add 5 on the left, also add 5 on the right. Now, when I say on the left and on the right, we're talking about on the left side of the equal sign and on the right side of the equal sign. So a minus 5 plus 5 comes out to be 0. They cancel each other out, and you only have y on the left side. And on the right side, 10 plus 5 is 15. And that's our solution. A solution involves a variable, an equal sign, and the number that variable is worth. We can always go back and check to see if our equation works. 15 take away 5. Do we in fact get 10? That is a 5. I wrote a curve that doesn't fit well there. So does 15 take away 5 actually equal 10? And we will say yes, that solution does work. All right, next one. We want to identify the side that has the variable. In this case, the variable's on the right. So we're going to look at the right side. What's bothering our variable x? X minus 7. So there's a subtract 7 there. And in order to get rid of a subtract 7, the inverse would be to add 7. So we're going to add 7 on the right. And in order to keep them equal and balanced, we will add 7 on the left. Now, you do not need to draw this vertical line segment, but it helps some people keep the left and the right organized. The minus 7 plus 7 cancels each other. We only have an x on the right side and the left side. A minus 4 plus 7, I have more positives than I have negatives, and there are 3 more. Now, some people would say that this is done because, Mrs. Fraser, you've got a variable, you've got an equal sign, and you've got a number, but we like them to be in that order. So your best final answer would be to rewrite it with the variable on the left and the number on the right. This one happened to already have the variable on the left and the number on the right. Next one, fractions. We are looking at the side with the variable. So n take away 1/5. The inverse of taking away 1/5 would be adding 1/5 on the right side of the equal sign, adding 1/5 on the left side of the equal sign. So the minus 1/5 and the plus 1/5 cancel each other out. They are worth 0. N equal sign, but I've got to do negative 7/10 plus 1/5, and they're not a common denominator. So over here on the side, I'm going to do a little bit of computation. Notice I'm not going to do it here in my algebra. I'm going to do it off to the side. So common denominator of 10, negative 7/10 plus 1/5 is the same as 2/10. And now I can do negative 7/10 plus 2/10. The negative 7 with a positive 2 leaves me with 5 more negatives than positives. And negative 5/10 is the same as negative 1/2. And then I'm going to go back to my algebra and put in that negative 1/2 equals n. Better answer would be n equals negative 1/2 with the variable on the left. Lots of little details, but none of them are hard details. Now, the next problem, t take away -6 equals 10. When you see this double, right, the subtraction and the negative sign both in the same place, we want to rewrite that. It is not ready for us to solve because there are too many signs. So t take away -6, we're going to rewrite that as t plus a +6 equals 10, minus a negative becomes plus the opposite, which is 6. Notice my T is curved on the bottom, so it doesn't look like a plus sign. You'll notice that the one that's typed, we did the same thing, a little curve on the bottom, so it does not look like a plus sign. But now it's an addition problem, and I'm going to look at the side that has the variable. There's a T plus 6. The inverse or opposite of adding 6 would be subtracting 6. If I subtract 6 on the left, I subtract 6 on the right so that they stay balanced and equal. T equals 4, and that one's already good. N plus 4 equals 9. I love this. It's already set up with a plus 4. I'm going to subtract 4 on the left and the right because plus 4 and minus 4 cancel. They are worth 0. N equals, and 9 take away 4 is 5. That one is easy peasy, already good to go because the variable's on the left. This one has the variable on the right, x plus 30 on the right. The inverse of plus 30, I was thinking already, was the minus 30. So I'm going to subtract 30 on the left and subtract 30 on the right. I still have my x on the right. I've got my equal sign in the middle. I just need to do 23 take away 30. If you wanted to, over on the side, if you needed, you could change that to 23 plus -30. Not necessary because you might notice, oh, well, she's trying to take away more than she has. Obviously, the answer is negative, and the difference between 23 and 30 is 7. So -7, but we prefer to have our variable come first. X equals -7. All right, so now we have one that might have just a smidge more work to it because it's got mixed numbers. M plus 5 3/4 equals 7 1/4. Well, the side with the variable over here on the left, M plus 5 3/4. The inverse of adding 5 3/4 to M would be subtracting 5 3/4. Subtracting 5 3/4. I have an M, I have an equal sign, and I have some computation to do. I'm going to actually do mine over here just because there's a little bit more room. I'm trying to do 7 1/4 take away 5 3/4. And at a quick glance, I notice that I can't do the 1/4 take away the 3/4. So this one I'm going to borrow. I'm going to do the regrouping here to the 7 1/4. Little note to myself, regrouping on this one. 7 1/4. If I add the 4 and the 1 together, I get a new fraction of 5/4 and take 1 away from the whole. And so I've got 6 5/4, take away 5 3/4. The 6 take away 5 is 1. The 5/4 take away 3/4 is 2/4, which is the same as 1 1/2. And then once I've done all this computation off to the side, I'm going to go back to my algebra and say M equals 1 1/2. So I've got this really nice clean algebra and any other computation that I might have to do off to the side. Last one, and this is a little bit tricky for people because it is an addition problem, but you'll notice that it's a -12. And if I were to just take away 12, -12 take away 12, they don't cancel each other. If it starts with a negative, even though it's addition, you have to think about what would be the opposite, or how do I get rid of a -12? The opposite, or getting rid of a -12, would require a +12. And if I put a +12 on the left side of the equal sign, I need a +12 on the right side. -12 plus 12 is worth 0. This is a positive x, so I can just say x. And -25 plus 12, I have more negatives than positives, and the difference between 25 and 12 is 13. So I would say -13. So yes, when you're doing these, you need to show your work algebraically, exactly the way we're modeling it here in the notes, in the lesson. If you don't have the work and you just have answers, you won't get credit because most of these answers we can come up with off the top of our head. Right now, what we're doing is we're practicing ground level basement building work for algebra. All right, some word problems. Christine is making digital scrapbooks after saving her current work onto a CD, or maybe you could say thumb drive. The CD is 5/6 full. If the CD was 1/3 full before she started saving, what fraction of the space on the CD do the new pages occupy? So what's the thing that we don't know? The easiest way to do that is look for the question or the question mark. What fraction of the space on the CD do the new pages occupy? That's the thing we're looking for. That makes it our variable. So we might say X equals space for new pages. So the space for the new pages plus there was already some stuff on the disk when we started, the 1/3, and now it equals the 5/6 full that we currently have. When we solve this, we're going to look at the side that has the variable. So we're going to look at the X plus 1/3 side and say, well, right now, the thing that's bothering the variable is that plus 1/3. So we're going to take away 1/3 on the left, also take away 1/3 on the right. And then over here, I'm going to do a little computation because they don't have a common denominator, which would be 6. So I've got 5/6, which doesn't need to change, and 1/3 is worth 2/6. 5/6 take away 2/6 is 3/6 or 1/2. So I'd go back over here to my nice clean algebra and say X equals 1/2. And I'm going to look back at why I was doing it. What fraction of the space on the CD do the new pages occupy? The new pages take up 1/2 of the CD. And you will notice that there will always be words in my answer. I will not just stop at X equals 1/2. If it's a word problem, people are not particularly interested in just your work. They want you to actually answer the question. The Jefferson Memorial in Washington, D.C. is 129 feet tall. This is 30 feet taller than the Lincoln Memorial. Find the height of the Lincoln Memorial. Okay, so the thing we're looking for is the height of the Lincoln Memorial. That's what we're finding, what the question is asking, so to speak, even though there's no question mark. So define the variable. I could use an L if I wanted, but notice if it's a lowercase l, it's got to be cursive. We would not use an uppercase L in this kind of algebra. L is going to stand for the height of the Lincoln Memorial. And you'll also notice that I'm going to put in parentheses feet because we're measuring in feet. The equation, the Jefferson Memorial is 129 feet tall. This equals 129 is or equals 30 feet taller than the Lincoln Memorial. 30 feet, and if it's taller, we would have to add 30 feet to the Lincoln Memorial, so 30 plus L. Now, if you had set this up with the 30 plus L on the left and the equals 129 on the right, that would work as well. And on the side with the variable, the L, we've got a plus 30 or a positive 30. So I'm going to take away 30 on the right. So I also take away 30 on the left side of the equal sign. And I'm going to get 99 equals L. And then I just need a sentence. The Lincoln Memorial is 99 feet tall. And that would wrap up our lesson.